Hello, boys and girls. This is Mr. Clemens, and today we are going to start discussing the topics of diffusion and osmosis. Diffusion and osmosis is something that ties very closely into the cell and the cell process. So we'll need to unlock all that information we've recently learned in our cell unit and put it to good use while talking about diffusion and osmosis. So you may be asking yourself, what is diffusion anyway? Well, diffusion is mainly the movement of particles, and it's the movement of particles from regions of higher density to regions of lower density. And I'll show you some pictures a little later, but the textbook definition is in yellow, and anything you see in yellow I want you to write down for right now. So diffusion, if I put a drop of food coloring into a glass of water, say I was using red food coloring, what would happen was all the water in the glass would become a shade of red. And that is because the food coloring is a region of very high density of red particles. And what's going to happen is those particles want to spread away and be equal throughout the glass. So they're going to go to the regions of lower density of red particles until they are equally spread out. So some examples of diffusion in our everyday lives are, one of the easiest ones is actually scents and the sense of smell. If someone is cooking bacon in the kitchen, the smell starts to dissipate throughout the house, spreading. And you know 3 rooms down the hallway that someone's cooking bacon. And that's because the region around the bacon is very dense with smell particles of bacon, so they are starting to move throughout the house and moving to the regions of lower density smell particles. Once you have an okay understanding about diffusion, we throw in osmosis. And osmosis is not the opposite of diffusion. Actually, it is a type of diffusion. And it's actually the diffusion of water through a semi-permeable membrane. Now, you may be asking yourself, what in the world is a semi-permeable membrane? A semi-permeable membrane is something that allows water to pass through, but not everything else. So, for example, if you put a gummy bear in salt water, the gummy bear would swell a little bit because it would absorb the water through osmosis. However, it would not absorb any of the salt from the salt water. So the gummy bear would not be salty on the inside at all. So that is a semi-permeable membrane in short. But the important thing to remember is that osmosis is a type of diffusion that moves water molecules. So it's not the opposite of diffusion, but it is a type of diffusion. So here you can see some different examples of diffusion. And one of the easiest ways to see diffusion is the large picture on the bottom with 4 beakers of water. You can see the first beaker is plain water, but they're adding a drop of purple food coloring. Now, and you can see throughout the process of diffusion, that purple food coloring begins to move to lower densities of purple. So you can see, if you look closely, you can see when it was first dropped in, it was a very dark purple. Well, that's because it was full of purple molecules. However, those molecules spread throughout the water and becoming equally spread out throughout the whole thing to make a nice shade of lighter purple. And if you move to the top left, you can see a cell. And you can see the outside of the cell when it starts is surrounded by a whole bunch of oxygen molecules. The little blue dots are oxygen molecules. And after diffusion, to the right of the arrow, you can see that the oxygen molecules are equally spread out through the inside of the cell and the outside of the cell. And the third diagram in the top right corner is pretty simple. The green dots are a solute, so it could be sugar or salt. anything in water, and you can see they are started at the higher concentration on the left, and they're moving to the lower concentration to the right, just to be equally spread out. And now let's take a look at some diagrams of osmosis. These are pretty much the same diagram, so let's just look at the bigger one to the right. It's just a little different way of showing it, but so what it's showing is there is two beakers of water, and the green line down the middle, that is a selectively permeable membrane or a semi-permeable membrane. And like I said earlier, semi-permeable membranes only allow water through, but not much else. So as you can see, it starts with the beaker on the left. The one side of the one side of the beaker is all water molecules, which are blue, and the left side of the beaker is sugar water, because there is sugar and water molecules on the left. Now, after a period of time, say 24 hours, if you looked in the beaker on the right, the first thing you notice is the water levels are different. And that's because the water moved through the semi-permeable membrane over from the right to the left, and the sugar couldn't move back through. So the water moved over to be with the sugar, but the sugar couldn't move. So that's why one side now has more than the other. So that's a really quick synopsis on osmosis and diffusion, but now we're going to look at some different ways to do this, and we're actually going to be doing an egg, or using an egg in a lab to further extend our understanding of this. So right now we're going to get out our books and we're going to turn to page 34 for some more diagrams. Thank you.